and I am glad to introduce you to this panel on replicability in AI, p-hacking, and implications in quantitative finance. I'm here with Dr. Horst Simon and Professor Lopez De Prado. It's an honor to be sitting between the two of you. I would like to start from where we are sitting, which is the office of ADIA Lab. So I would like to ask you about introducing to the audience ADIA Lab and the vision of the laboratory.
Good afternoon, good evening, and good night. If half of the 5,000 users are in East Asia, they really must be sleeping now. And good morning to collaborators in the US and in the Americas. It's a great pleasure to be here with our colleagues from CrunchDAO and talk about ADIA Lab. ADIA Lab is now just about a year old. We were created on December 2nd, the UAE National Day last year. And so maybe some of you had the chance to participate in the ADIA Lab Research Symposium that took place just 2 weeks ago, also here in Abu Dhabi. But for those of you who didn't join the streaming information from the symposium, here is what ADIA Lab is about. ADIA Lab has been created by ADIA, a large sovereign wealth fund in Abu Dhabi, to investigate computational and data science with a vision that the future and the large challenging problems in the future will revolve around computation and data. That computation and data will be the tools and technologies to solve the important problems that the society faces. And there was a grand vision at ADIA, and Marcus, who is sitting here with me, and some of his colleagues had this vision that said it is important to engage in basic research in computation data, not just financial, but that there can be learned a lot from what is done in other disciplines that can be transferred back possibly into ADIA. But right now, we're focusing on basic research. So that's one element. The other element is that we are rooted here in Abu Dhabi, and it's part of the UAE longer-term strategy to become a digital economy powerhouse. And so it is important to build a network that is rooted here in Abu Dhabi, but is connecting to researchers all across the world, and is establishing Abu Dhabi as a hub for international collaborations in computation and data science. So it's a great pleasure to work with CrunchDAO, who has a similar vision, and you're talking about a bridge, and I'm talking about a network. But what we mean is the same thing. We want to connect to all the smart people who do data science all across the world and connect them and make sure that at some point they find a intellectual home here. So these are the thrusts, and what do we try to accomplish? I would like to say that ADIA Lab will have been successful if in 5 or 10 years we can look back at this year or next and then point to 1 or 2 research topics that we've been solving, papers that have been published, and say, these were major breakthroughs in terms of science, but these may have been also major breakthroughs in terms of building the foundations for a company that has grown into a major company here in the UAE and then worldwide. And so there are, I'm very much convinced that what we need to do here is basic research, and where I previously worked, it was called mission-driven basic research. You use the tools and technology of basic research, but you never forget that you have to solve an important problem. And that's the philosophy that is employed here, and this has to be done also in a multidisciplinary way. So looking backward, we'll see some great successes. And my past experience, you could never see from the seeds what great success will come out of the seeds. So we have to have many seeds here.
All right, thank you. Thank you. And Professor De Prado, maybe you can add something on, let's say, the attractiveness of doing science and doing entrepreneurship in Abu Dhabi and the UAE. In fact, when you first met, actually, you recommended the positive environment, the regulatory-friendly environment for innovation. Do you have something to add? And maybe to share even what you already said, but for the listeners, something to add about joining the ecosystem.
Excellent. Thank you, Matteo. The UAE offers today one of the best environments in the world for conducting research and to be entrepreneurial. The country has a very clear vision as to the importance of the digital economy, the importance of diversifying, and at the same time it has a number of competitive advantages. One of them is the absence of legacy. You can come here and start new and do things that do not exist and can be done differently. You don't need to fight with the legacy of a number perhaps of regulations that were set up to tackle problems that existed in the 1950s but that are no longer relevant today. And these laws remain in the books, and they remain, and they take a life of their own and make progress very difficult. So the lack of legacy is definitely a competitive advantage. Another one is the clarity of the goal, the vision that the UAE must be a hub for new technologies, for breakthrough technologies over the next few years. And that has attracted a tremendous amount of researchers who have relocated here through the Golden Visa program. And this network offers opportunities that do not exist in other places. So the UAE in general and Abu Dhabi in particular are becoming the place to be. These accompanied, of course, with abundance of capital. Abu Dhabi is considered now the capital of capital. That, of course, helps a lot because you can have great ideas, but if these ideas cannot be funded, they don't go anywhere. So, to summarize, this is a place where you can do things that are no longer possible in other places, or where there is a tremendous reservations and difficulties that need to be overcome for doing them. You come here and you have some ideas, and they are more likely to succeed than in other places.
Mm-hmm. Right, thank you. Thank you. So I'd like to jump straight in the subject of the panel, which is replicability in AI. So starting from definitions, what is the replicability crisis? What is p-hacking? And most importantly, I would say, how have these issues shaped your way of thinking, your working ethics, I would say, in thinking about experiment setup and so on? Maybe Dr. Horst.
So I would like to go back into the distant past, in the late 90s, when I had my first very important and future-directing encounter with a challenge in reproducibility. And it was a very important challenge because I was at Berkeley Lab at that time, and there was a researcher who had done a couple of experiments and claimed that he had found element 118. And maybe some of you remember this. It had turned out later on that this was fraud. But it took 2 years to detect this, and it took researchers in Germany and in Russia trying to reproduce the experiment. And the experiment was well described, but they could not reproduce the experiment. And then they issued their doubts, and then the lab had to launch an investigation into that case. And so you'd think this was a nuclear physics experiment, but it came down to data. And the fact was that the researcher who had produced the results had used a statistics package, SAS at that time, on a Sun workstation and produced the results where the results based on the statistics package indicated that the experiment had produced a new element. And so now the interesting challenge that came about this was 2 years later when the investigation was launched. They could not get, if they tried to reproduce the data analysis, they could not get access to the version of SAS. They could not reproduce the compute environment. The Sun workstation the researcher had to run on did not exist anymore. And even if it had existed, the Sun had upgraded the operating system multiple times. And so in the end, the overwhelming evidence convinced the researcher to admit falsification. But it raised the big issue, if we rely so much on computation in the future, how do we assure reproducibility? And now, if you take that simple example, which was a simple package on a workstation, and translate this into today and think about large language models with billions of parameters running on highly tuned high-performance computing platforms, running in low precision arithmetic that is not conforming to any standards, then it looks to me as if it's almost hopeless to expect reproducibility under those circumstances. So this is my short historical perspective, and I try to put this in an anecdote because anecdotes are things that everybody remembers after a presentation.
Yeah, indeed, thank you. And this is, sorry.
Let me complement that excellent answer by breaking down the crisis into 3 parts. Number 1 is the reproducibility crisis, which is what Horst just mentioned. That's outright fraud, right? When people manipulate data, etc. The second aspect is replicability. The results are reproducible in sample, but they do not generalize out of sample. Why? Because the model is overfit. And that's a result primarily of multiple testing. You can rerun multiple times a test or various experiments on a given amount of data, and eventually you are guaranteed to make a false discovery. Remember, people control for a 5% false discovery rate on one test, but once you conduct your second test, it's no longer 5%. It will be 7%, and the third test, 10%. Eventually, you are guaranteed to make a false discovery. Statisticians learned this very quickly, very early on, already in the 1930s, but nobody paid attention until, in the end, Ioannidis published a famous paper in 2005 with the title, "Why Most Published Research is False." Right. And now people pay more attention. In finance, this is, of course, a tremendous problem because we have a data set of, let's say, 20 years that takes 20 years to produce. So we don't have out of sample. We cannot go to a laboratory and create a new data set by running new experiments. So this problem is compounded in finance. And then there is the third aspect. I just mentioned reproducibility, replicability. The third aspect is spuriosity. The association may exist, but it may not be because of the process that you are modeling. The fact that you have a regression does not, and the regression has a high R-square, does not mean that the specification is correct. Your beta can be severely biased by a misspecification error. So there are these 3 aspects, and they have very different consequences. Of course, the first aspect, reproducibility, is outright fraud. The second one is not fraud per se. It is being a bad researcher. You just don't follow correct statistical protocols. But that's widespread anyway. Even the most prestigious journals worldwide publish constantly research where there is no adjustment for selection bias under multiple testing. And then the third aspect is spuriosity, which has to do with having a causal explanation for the choice of a specification.
Right, right. So maybe today we can push forward a bit the line and put the second category in the first one a bit more and try to educate people about the need to be diligent, I would say, disciplined. Maybe to expand the discussion, not only in quantitative finance, also health sciences. This was a focus of the symposium. But there is an interesting dialectic relationship between the need for privacy of data, so the importance of having safe storage of data associated to finance or health. But at the same time, because one needs to take optimal decisions, so this could be policy making at the health level or even optimal capital allocation. It's still a policy making, let's say. It's important to have a system that's transparent, reproducible, understandable, even causally explainable. So how do you see ADIA Lab moving forward with this tension, Dr. Horst?
So I think that is, of course, what you're addressing is the fundamental tension between privacy and transparency that is in health data. And so we need to address privacy and at the same time maintain transparency and reproducibility in science. And there are a number of technical solutions. So you mentioned, for example, differential privacy as a technique, and also the opportunity to develop secure data sharing platforms and protect privacy of data while allowing access for data analysis. And at ADIA Lab, we have a number of advisors and scientists who work in this field. So we had a very intriguing presentation by Shafi Goldwasser, who talked about this topic in the research symposium. And we also have some expertise from MIT in this field. So we are trying to leverage this into our research agenda. I think another great example is what has been done here with CrunchDAO is to use synthetic data or obfuscated data that mimic the real data characteristic without compromising the individual privacy. Now, the challenge to actually get synthetic data right is a huge challenge in itself. And in my experience in engineering science application, a lot of people just say, oh, we create a random matrix. And the random matrices are not real. They don't reflect what a scientific or an engineering application really looks like. They may have other important applications like you just described, but they are not useful for testing scientific engineering applications.
And why is that in particular?
I'll give you one example. There is, in my work, I have looked at sparse matrices. And so you do a sparse matrix algorithm. If somebody says, oh, I'll just create a random matrix where I randomly fill, following some distribution, the entries in the matrix, that does not create the structure, the deeper underlying structure that you might have in the data. Mm-hmm. So this is why I actually liked the images that were shown earlier, that there is often structure in data, and engineering applications can, if the algorithms are done right, they learn this structure.
Mm-hmm. I see. And more about this tension, maybe it's a different kind of tension, but more in quantitative finance, is between the need for financial institutions to be robust and replicable and based on scientific method, I would say, not being a phenomenological manifestation of something. But again, there is this need for constant innovation. So the pace has to be fast and, again, disciplined. So how do you see this influencing your way of working?
Absolutely. Investing involves a fiduciary duty. Investors rely on the institutions that manage money to behave in their best interest. And behaving in someone's best interest requires a number of constraints, if you will. One is to do what is ethical. You do, even if something is profitable, if it goes against the ethics of the investor, that's not something that you cannot do. So black box solutions are not always optimal in a broad respect. The second one is it needs to be explainable. If you have a solution that appears to make money, but you do not really know why, you may be falling short of your fiduciary duties. Why? Because things could change in a way that the system will make systematic losses, and you will not be able to explain why it's making losses, just as you were not able to explain why it made profits in the first place. So explainability is very important. A third aspect is, in order for a system to comply with the fiduciary duty, it needs to be trustworthy. The fact that something appears to make profits is not enough to earn the confidence of the investor. It needs to have a real scientific explanation that goes beyond understanding what are perhaps the drivers of the forecasting power, but what is the underlying mechanism that is responsible for these observed associations. So not only we need to understand what are the explanatory features, the features that explain the forecasting power, we need to go beyond that and understand what are the connections between those features, what is the mechanism that makes us believe that this outcome is most likely. So as you can see, machine learning has a very important role to play in all of this, but in investing, but not in the way that most people think. Most people think of machine learning as a black box solution that will help us obtain some profits by producing very accurate forecasts. The better use of machine learning in investing is to help us develop the investment theories that we need in order to obtain these better forecasts. And machine learning happens to be very helpful because it allows us to understand complex systems, as you explained earlier, where there is a very varied number of variables involved in a phenomenon, and discovering these variables can only be done through nonlinear, very complex estimators. So machine learning has a very important role to play in investing, but we need to understand that not everything in investing is just forecasting. We need to comply with the fiduciary duty that we have towards investors, which is much more than just running black boxes.
Right, right. And do you see a causal framework innervating, let's say, a purely statistical, a purely associational world? Do you see? Is there room for purely associational research?
In some aspects, yes, but not only associational. In the end, to earn the trust of an investor requires a deeper understanding than just these two things tend to go together. No scientist would be satisfied just by the fact that two things happen together, right? This is just the beginning of the scientific method. You observe these two things occurring together, and then you develop a falsifiable theory as to why these patterns observe. And then you subject this theory to falsification over and over and over again. So investing very often remains in the first stage of the scientific method, just what is phenomenological, which is often a recipe for disaster, because eventually there is the black swan event that that puts a company out of business. So the only way to prevent a black swan is to develop a theory that explains why this black swan is possible, and therefore you should manage that risk.
Right, right. I have a follow-up. It's a fascinating topic, but are you not afraid of, let's say, even every falsifiable scientific theory, let's say, has its limitations? So do you see the need, of course you see this, but do you see the need of a probabilistic approach to causality?
Of course, yes, absolutely. There are never guaranteed outcomes, and we see that in medical research all the time. The fact that you submit yourself to a treatment does not guarantee cure, but nobody would reject treatment of a serious condition just because success is not guaranteed. Sometimes you may accept the treatment even if there is only a 50% chance of cure. And with investing, the same, right? Yeah. There is never a guarantee of success. Otherwise, it would be a risk-free rate. Right? Otherwise, it would be just like investing in the safest security. There is always risk involved, and that risk needs to be rewarded.
Right. Right. And do you think it's necessary, particularly in finance, in which, let's say, the possibility, this percentage is 2%, let's say, of something happening, then at a certain point, causality blurs down into something purely associational. Do you think causal inference has to learn from techniques developed in machine learning for low signals-to-noise ratio and deal with, let's say, discovering causal structures in financial markets?
Machine learning is an integral tool of causal inference because we never know causal graphs. We need to discover those graphs. And it is machine learning techniques that allow us to discover those graphs that we're going to posit as a falsifiable theory. So there is no need to separate machine learning from causal inference. In fact, they go hand in hand. Causal inference allows you to adjust the observed data set in a way that you control for confounders, avoid colliders, etc. But to determine what is a confounder, a collider, a mediator, you need machine learning techniques. So it goes hand in hand.
Right. Thank you. Dr. Simon, a question about the role that institutions can play to promote, let's say, replicable research practices. Can institutions do something to deal at least with the two families?
So I think that the current push in terms of scientific publications to include code and data is absolutely essential because, as I said before, if you don't have this as part of your publication, how can the average scientist who wants to really understand what is said there follow up on it? So I think this is a very positive practice that has recently gotten a lot of traction. And I think that this should be also institutionally supported, and by that I mean that universities should, maybe I say this way, should give more academic credit to researchers who publish software, for example.
Mm-hmm. Yeah. Right.
And this is not always yet accepted in academic practice, that a software publication is as important as a paper publication.
Right. So the same pressure for discovering false associational claims in quantitative finance is happening. But how can institutions adapt to this change, let's say, in which professors are still pushed to publish as much as possible sometimes?
Since I had most of my career in a national lab, then it's always easy because then you just need from top down a message saying this is how we do it, and then you'll get the outcome. And I know a good example was that about 2005, the lab that I was at, Berkeley Lab, changed in the annual evaluation process of scientists the value that was put on patents, and so everybody was told that a patent would be as valuable as a scientific publication. So with the incentive being put there, more patents were created.
Anything to add?
No, it's a perfect answer.
Great. So a question, Professor De Prado, about your contribution to crowdsourcing financial research, and maybe if you can try to associate to what we said before about avoiding purely associational claims. But you contributed to a number of projects in the past about crowdsourcing financial research, including Quantopia and Numerai, for example, beside writing a number of books and papers. Why do you think crowdsourcing research is relevant, and mainly what open challenges do you see in the field?
Yes, crowdsourcing has a very important role to play in investing, and I like very much the metaphor that you presented earlier with the Kasparov against the world tournament. Why? Well, we all understand the power of ensemble algorithms. We all understand the power of boosting. We understand the power of the collective wisdom of the crowds. And crowdsourcing opens the opportunity for further specialization in investing. Tackling the complexity of financial data sets is a tremendous endeavor. These are data sets that exhibit structural breaks, missing data, outliers, regime switches, non-stationarity, serial dependencies. These are very complex dynamic networks. As a result of that, it truly requires domain experts to analyze these data sets. By crowdsourcing, what you do is you convert a problem, you break down the problem of developing investment strategies into logical units. CrunchDAO is responsible for taking unstructured data, structure it, and cast this investing problem as a forecasting problem. And once the problem is presented as a forecasting problem, any data scientist in the world is better equipped to solve that problem than the best economists in the world,
yes,
the best investors in the world, etc. So by breaking down the problem of investing into these logical units, you lever the power of the collective endeavor. And crowdsourcing is only starting in finance. I think that in the future we will see that more and more investment firms structure themselves in a way where some teams are going to structure the data, other teams are going to cast the investing problem as a forecasting problem, then they are given to researchers worldwide that essentially operate as this ensemble algorithm, right? Where you no longer rely on a single algorithm for making that decision, you rely on thousands and thousands of algorithms. So I think that it's going to be truly the way the industry is going to evolve.
Right, right. We had a nice analogy in saying that every member of the community is a medium learner instead of a weak learner of an algorithm. On the decentralization, I think this is a subject that has always been a focus for CrunchDAO, which is to be able to, of course, build machine learning models without a single point of failure, which are also trustable and interpretable. So, Dr. Simon, if I can ask you, if you see, and you mentioned large language models, if you see in particular today the risk of a centralizing tendency in AI and how this concentration of power could evolve in time and could be mitigated?
So I think the biggest challenge, and of course this is my background in AI making progress, is the fact that the amount of computational power that is needed, if you just do the scaling that everybody's saying, is getting more and more excessive, and therefore only a very small number of firms can actually provide the tools and provide computational infrastructure. And so, of course, a lot of folks talk about OpenAI today. And what is forgotten is that the big investment that Microsoft made in OpenAI was actually by giving them computer access. And so the value of computer access that Microsoft provided at that initial investment was labeled of the order of $10 billion, which is absolutely mind-boggling. But what I'm concerned about is that this scaling, of course, has another downside, is that I don't know when we will hit the greenhouse gas limit for all those big supercomputers being built for AI access. And so this is what actually concerns me today, and so I think the scaling up of large language models will have both the computational and also the financial limits. So therefore, no, I'm not being asked, but I just don't believe that we're on a path to AGI in this way. Because there are natural limits, and it's not, we're building computers that don't function like the human brain, and so I don't think we're on the right track with large language models.
Right. And related to this, what's your take on how blockchain technology, most of which is relying on purpose computational costly?
Well, that's a good question. I just wrote this on my notepad today. I should talk to Alex Lipton if we should explore this on a paper when blockchain will burn up all the oil that we have. So, but it's the same question, is that there were these reports that at one point the state of Texas computer centers that were built there are taking up more energy than the rest of the state. And so I think this is the same question. I think that we need to look at the potential for scaling up current efforts. And I don't have an answer on this one yet, but we have the tools here at ADIA Lab to explore it. And it's a question that I'd really like to explore.
Right. So
shouldn't put this on the record, because next year you ask me, so what happened to your blockchain and computer electricity consumption paper?
Yes. No, but beside the paper, I think we already had this discussion months ago about the need to rethink about computational machines. And I would like to ask you again today, for people that didn't attend, about how do you see our way of thinking about computing machines forward?
Well, I have this one slide, which I always use in my presentation, which is not my own, but which shows that computer architecture and computer technology has been going in a direction of more and more power consumption. So if you even look at the latest version of NVIDIA, it's 4 times more powerful, but also takes 4 times more energy. And so this is the wrong direction, because if you look at the human brain is in the other direction. The human brain works on a much lower cycle time, on a millisecond cycle time, and only takes about between 20 and 100 watt. So we need to build computers that are more energy efficient and use different architectures. So a good friend and collaborator of mine, Dharmendra Modha at IBM, has always pushing this point. And I just think that at one moment in the near future, the power consumption will hit limits on both the AI applications and also the digital finance, the blockchain applications, and then it will be a reversal of architecture.
Okay. Anything to add, Professor?
Again, perfect answer.
Okay, then I guess we can close this panel here, and I believe we have a 5-minute break, and then we will move forward to analyze the results of the competition. People, I'm sure, are hating us for taking so long to reveal the winners, but we're coming.